Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in building and urban efficiency. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. Now, you can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Today, we have Drew Turner with us, Danfoss's Global Marketing Manager of Sector Integration, and we are really excited to talk to him about heat pumps and heat pump technology and where the industry is headed. Drew, thanks for joining us.
Yeah, thanks for having me.
No problem. Let's jump right in. This is going to be a shorter show today, so let's get right into it. Drew, briefly explain what are heat pumps and how do they work?
So heat pumps, explained simply, is every chiller is a heat pump and every heat pump's a chiller. Any mechanical system where you're moving refrigerant and rejecting heat and absorbing heat and rejecting heat is in effect a heat pump. True to a purist, so to speak, from a product design side, a heat pump is a refrigerant side reversing system where you're alternating between making use of heat and cooling. But to us sector integration folks, where the theme of what we're trying to help move the industry in the direction of is making use of both all the time. And a heat pump in that case is most frequently is a water to water, where you're absorbing heat in the evaporator on a water side system or a hydronic system, and then rejecting the heat through the condenser on the other side, also through a hydronic system, and making use of both all the time.
Yeah, and I think that's a key point. So I think a lot of people have heard of heat pumps. I have one in my home. These are air-to-air heat pump. It's drawing heat from the ambient air and using that to move heat one way or the other in your home. But we're talking about commercial applications here, right?
Large-scale commercial applications, absolutely. But that's a critical point. Yeah, air source as well as air supply, so to speak, are both alternate versions of the technology from an application standpoint, especially when you get into the smaller residential systems.
Now, we've talked on the show a lot about, decarbonization policy, whether it's natural gas bans or building emissions laws or state emissions goals and policies. But what are the key benefits of heat pumps in terms of decarbonization and efficiency?
Yeah, there's an incremental approach to the benefits. So starting with the baseline of and the drive to heat pumps and the electrification of heating, as you know, as well or better than I, is really driven by the integration of renewables into the power grid. And so the corollary with that is if you're going to benefit from the decarbonization based on integrating renewables into the power grid, then electrifying heating should take place as well to increase that decarbonization potential. And heat pumps, starting with the baseline of just going from fossil fuel source heating to heat pump systems, are a much more efficient form of obtaining that heat, because all you're doing is moving heat and boosting the temperature that it's applied at, as opposed to transforming energy with the burning of fossil fuels to get that heat. And so that factor, which is in just as very simple terms, about a 3-to-1 efficiency advantage of a heat pump, drives the associated decarbonization potential of that heat pump system, even utilizing 100% fossil fuel as the electricity source in an electricity system. So from there, though, as you integrate in more renewables into the power grid, the decarbonization potential goes up. So that 3-to-1 efficiency benefit means that you have about a 60% decarbonization potential with the baseline, just based on the efficiency advantage from 100% fossil fuel source power generation. But as you integrate in more renewables into the power grid, that decarbonization potential goes up about 3% for every 10% increase in the power generation that comes from renewables.
Yeah, and I think that's such a key point because so often we hear kind of opponents of electrification or decarbonization, at least at the building level, say, well, you're still producing that electricity using fossil fuels. But what you're saying is that even if we do, use natural gas to produce the electricity that runs the heat pump, just switching to that heat pump from a fossil fuel fired boiler or furnace or what have you is going to give you a pretty big boost in decarbonization.
Based on the resulting efficiency. Exactly.
Yeah, and then it enables you to electrify the grid and totally decarbonize that heating element when you're running on renewables or storage or whatever it is, and using an electrified heat pump. I mean, I think it's just a slam dunk, and I think that story doesn't get told enough.
Exactly. Yeah, it's that long-term focus. It's that eventual world where we're over 80% or so renewables in the power grid that you're really driving towards, but it's the incremental decarbonization getting there. That's the benefit today.
But outside of these larger scale systems you mentioned, whether it's geothermal or using a heat source that you can kind of scale, like a wastewater treatment plant or a data center, and using that waste heat, what are the challenges in commercial buildings right now in terms of implementing 100% electrification?
It's really the scale, the scale of the cooling system and the heating system, and the constant load on both sides is really hard to get, and that's where the storage comes in. The other corollary here is energy storage becomes more critical, and the struggle is that if you're going to get 100% of your heat from recovered cooling, rejecting heat or absorbing heat through the cooling system to then utilize that heat on the other end, then you have to have a perfect match of the loads, and you never have that. And especially the smaller scale you go. As you go bigger scale into district energy systems, you have a much better balance of those cooling loads and heating loads. But on the smaller scale and the individual building scale, that's the biggest struggle, is how to, if you're going to optimize a building to be net zero eventually, and getting 100% of your power from renewable sources, and therefore fully decarbonized, then you have to have that perfect balance. And to get that perfect balance, you have to integrate storage, either cold storage or hot storage or both, or electricity storage as well, into that building. But that need for storage, again, as the larger scale you go into a district energy system, for example, then that complication becomes less because you need less storage. Because
Unfortunately, we just don't have the district energy systems that they do in Europe, and it's going to be hard to build them into the existing infrastructure that we have. Where are we with air to water heat pumps? Something that could replace a chiller boiler combination in the future.
So the technology, actually, back to that question on the technology. So from an efficiency standpoint, your baseline is an air-to-water heat pump. You're in the 3 to 3.5 COP range with an air-to-water heat pump, but the technology is getting better. And it's getting better in both the capability of the technology to operate efficiently at high differential temperatures and pressures, as well as lowering down that minimum point of the operating temperature of that air-to-water heat pump, absorbing heat in very cold climates, said in layman's terms, right? That is really the focus of the improvements of the technology, and then the system efficiency, the various improvements that you can make, not only in the compressor optimization, but the optimization of the heat exchangers in the system design to improve the efficiency of that heat pump, which is, from that baseline of operating with ambient air as the source, is not an extremely efficient solution. But to your point on, you mentioned data centers earlier, we kind of group everything to simplify it into from the baseline of air to water ambient air as your source, and ambient water as a very similar operating temperature and efficiency system. Then you have comfort cooling as your heat source for a heat pump or a heating load system. And then you have optimally your critical facility cooling systems that operate at very high cooling temperatures as your recovered heat source for a heat pump system. From that baseline and going up to that second level, if you will, of the comfort cooling, you have about at least a 10 to 20% efficiency benefit. And then that critical facility cooling system, such as a data center, which are, by the way, increasing as we speak, their cooling operating temperatures, you have an additional 20 to 40% higher efficiency of that heat pump system because of that higher temperature recovered heat that you get as your source.
Yeah, I think trying to use these heat pumps, particularly as data centers become more prevalent, and even these edge data centers that are located in urban areas, I think we can use those better in terms of a heat source. But and I know the DOE is involved in the cold climate heat source challenge with many of our largest customers, largest OEMs in the world working on this stuff. So I think the technology is going to be there soon. But I'm a big believer in we need to do something now because these boilers last 20 to 30, even 40 years sometimes. So for the building owners that are looking to make a move and replace or install a boiler now, we need to have a decarbonizing option available for them. And I think these dual fuel systems using heat recovery chillers in combination with a very efficient boiler can really, even if you don't go 100% electric, can really help reduce your carbon footprint in your building right now, today. And they're available and very efficient.
Yeah, those hybrid systems, you're talking about hybrid systems, and hybrid systems is the reality for a number of reasons. I mean, if you're going to have an efficient heat pump system, you have to lower down your demand side operating temperatures. And that's not necessarily feasible in all retrofit applications. It's very hard to do, especially the larger scale you go. So in the interim, what you can do is you can take an existing boiler system and add a flue gas scrubber, for example, to it, using the cooling of that flue gas scrubber, which also takes out contaminants from the atmosphere, not only CO2, but other contaminants from the atmosphere, and recover that heat through a water-to-water heat pump to partially electrify that heating system as well. That's one of the first applications we did with our oil-free technology in a large-scale district heating heat pump system, was a flue gas scrubber, and it's a fantastic incremental hybrid approach to decarbonization.
Yeah, and I think it's key because, like I said, these boilers can last a very long time. So if a building owner invests in one now, he's not going to be able to decarbonize probably for a long while, unless he's forced to upgrade that system before it's the end of its useful life. So I think we really do need to have some options available now, and there are. I think there are a lot of good options, like you mentioned, to really reduce your carbon footprint, if not to zero, to fairly significantly down to 33% or whatever it is for your particular building. Thanks, Drew. I really appreciate you joining us. Like I said, this is a short little episode. Anything to add before we close up here?
What I was mentioning earlier on the demand side, one of the things that we're advocating and which Danfoss can really help with is a comprehensive approach to decarbonization and electrification of heating, both on the supply side and the demand side. As I mentioned, that demand side change is arguably more important than the supply side change and the change to from steam heating systems to hot water and hot water to lower temperature hot water. If you do that and you don't change, you have to get to the lower temperature hot water, you have to make the demand side changes as well. So the whole point, or the main point, is a comprehensive approach to decarbonization and electrification is something that we can help with and something that is critical to really achieve the goals.
Yeah, absolutely. This is not something to be taken lightly or to be only attacked at one point in the value chain. I think a comprehensive approach really is necessary. Well, thanks, Drew. I really appreciate your time. And that's it for this episode of the EnVisioneering Exchange. Again, I'd like to thank my guest, Drew Turner, Global Marketing Manager for Danfoss and Sector Integration. And don't forget to subscribe to the EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Lastly, if you enjoyed this episode, don't forget to rate, review, and share with your network. We really appreciate it. Again, thanks for listening. I'm John Sheff, Director of Public and Industry Affairs for Danfoss. We'll talk to you next time.